Hello, 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 everybody, and welcome back. Thanks for joining me once again. We're looking at question 21 on the 8th grade Gauss paper from 2005. In the diagram, a circle is inscribed in a large square, and a smaller square is inscribed in the circle. If the area of the large square is 36, the area of the smaller square is... So we're not given a whole lot of specific information. We just know the area of the large square. But knowing the area of a square is enough to get the side lengths, and I think from there we might be able to work some of this out. Let's draw our picture in our notepad here. So here's the large square. We know he has area 36, but if you have a square, the area is s squared, but we know the area is 36, so s squared has got to be 36. Not that hard to see. S is 6. Square root both sides if you need to. So instead of s, we can just write 6. So 6 is the side length of the large square. Now inside here we have a circle. Let's see if we can draw it at least a little decently. Okay, and inside there we have a square. Now their picture has the square sort of aligned with the other square. Not at all required. Just imagine this circle was a wheel and you could rotate it. The square inside is going to rotate, but the outer square isn't. It's not really going to change anything. Okay, and we want the area, the perimeter. What did we want here? The area of the smaller square. Okay, so what have we got? Well, we've got some interesting points of tangency between the large square and the circle. So I always connect up points of tangency to the center of a circle, and we get right angles when we do this. But we had right angles in the square, and so it looks like we've got tiny little right angles here as well. Okay, so that's all well and good. Now, we've got radii here. So we've got a rectangle up here, this sort of reddish rectangle. And it's got side lengths r and r. So it's actually a square. And we could do this with each one of the radii we drew. We get r's everywhere. So for the radius of r for the circle, we can see pretty quickly that 2r is 6, the side length, because we've got 2 r's here and they make up the whole side. So what does that tell me? R is 3. Okay, so how does that help us? Well, let's just for a second draw the circle with the smaller square. I think we're done with the large circle for now. If I run into trouble, of course I can go back, but for the sake of clarity, I'm going to redraw a simpler diagram without the large square. I know the radius of the circle now. Now, I don't have sort of sides that are tangent to the circle, but I do have these points on the smaller square, these corners, which are on the circle. So I always try and connect these sorts of things up to the center. Good habit to get into. And I know that each of these blue lines is going to be a radius. So we've got 3's here. Okay. So, what else can we do here? Well, you could either start working things out with angles, or you could say, well, it's a square, so by symmetry, we're going to get right angles everywhere here. And if we've got a right angle here, I'll just get some purple. If I've got a right angle here, between these two radius lines, take a look at this this purple triangle here. I've got a right angle triangle. 3, we got a right angle there, 3. So by Pythagoras, I could work out the side length, maybe we'll call him t, of the smaller smaller square. Now, why is this helpful? Well, what do I want? I want the area of the smaller square. If I knew the side length, I'd be all set. Because the area is just t squared. So if I knew t, I'd be done. What does the Pythagorean theorem tell me? It tells me t squared is 3 squared plus 3 squared. Now, I could solve for t, or I could realize, hey, I don't need to, because the answer I want, I don't care what the side length is, I really just want the area. And if I can get the area t squared without having to solve for t, so much the better. It saves me just a fraction of time as long as I can realize this. Now, if you didn't make that connection, that's okay. If you just said, okay, I want to solve for the side length of the square, and then I'll do other stuff later, that's fine. It's going to cost you maybe one calculation on your calculator. It's going to be 3 root 2 is t, and then you're just going to square that. Okay? But if you can make this connection, so much the better, because it just saves you just a fraction of a second that you could spend on other questions. So 3 squared is 9, so we get 9 plus 9, or 18. So the area of the smaller square is 18. They didn't give us a units, I don't think. So, yep. So we're just going to take a look here, and I see E, 18. So there we go. And that's question 1 there. Or not 1, 21. First question in part C, question 21. So we've got 4 more questions to go, and then that'll be it for the contest. Join me in the next video for question 22.